Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our Chapter 10 test review. We're going to do questions 1 through 14 here from page 587. We're going to skip over number 8 as well just because it doesn't show up on our test. And just really hammer down the questions that we really need to get going on. So for numbers 1 and 2, we're going to find the measure of each numbered angle in circle P. So for number 1, angle number 1 is going to be 72.5 because it's an inscribed angle. So when it's on, sorry about the bell, when it's on that angle edge, it's going to be exactly half of 145. So we just did 145 divided by 2, okay? But then angle 2 is going to be 145 because it's a center angle. Okay, number 1 here and number 2 can also be found with enough information. Since number 1 is directly across from diameter, we can say angle 1 is 90 degrees. And since angle 2 is showing a tangent and we have a semicircle at the tangent, we can also say that angle 2 is also 90 degrees. Okay? For question number 3, we have to use some more math skills here. So let's start with angle number 1. Angle number 1 is outside the circle. So to find angle number 1, we're going to do 1/2 of the arc. So big arc minus small arc. So 96 minus 38, and we should get 29 degrees for angle 1. Okay. Angle number 2 is inside the circle. But notice it's not a center angle. So for angle number 2, we're just going to add those intercepting arcs and take 1/2 of them. So 96 plus 38, and then divide by 2, we get 66 degrees. Okay. Now, because we have angle 1 and angle 2 now, once we get to angle 3, I want you to think about angle 3 being a part of a larger triangle. We know that angle 1 is 66, okay? And because angle 1 is 29, my bad. Angle 1 is 29 degrees, and angle 2 we know is 66 degrees. So the thing I'm going to do first here is take 66 away from 180. Because it's making a straight line, this will be 114. So angle 3 is just whatever leftover is from that. So 114 plus 29 gives me 143, and 143 subtracted from 180, I'm getting 37 degrees. This one's an inscribed angle, so it's also within the triangle on the edge, but I looked at it as more so of a triangle, with an angle within a triangle. All right, number 4. Also had to do a little bit of extra thinking here, especially when you get to angle number 2. Angle number 1 is outside the circle. So in order to find this one, we're going to take 77 minus 48 and then half it. So angle 1, 1/2 of 77 minus 48. And I'm going to get about 14.5 degrees. Okay. Angle 2, however, is outside the circle as well, and is a part of two tangents, but the 77 doesn't matter anymore because you have this entire big arc to deal with. So what we have to do for angle 2 is add 215 and 48. That gives me 263. So that's going to be my big arc. And then this missing arc would just be 263 from 360. So 360 minus 263 is 263 from 360, 97. So this one now is 97. So minus 97, then divide by 2. We should get about, where are we at? 263 minus 97 divided by 2. We're getting 83 degrees. Okay. All right, number 5. Use the diagram. This is going to take us to like lesson 10.6, where we have the secants and tangents and how they apply. If AG is 2 and this length is 9, then what can we do to find BG and then GF? Okay, so that just means 2 times 9 is equal to 3 times x, or 18 is equal to 3x, so x has to be 6. Okay, for the next one, just reset here, CF, so that entire length is 12, and CB is 3. So automatically I know I'm going to have to use my 12 by 3 because CF is the entire length. And then CD is 9. So find CE. So 9 times what can also be 12 times 3. So that'd be 36 is equal to 9x, so x is equal to 4 for this one. And then for my number 7, BF is equal to 9, CB is equal to 3, find CA. So CA would be squared, so let's say x squared is equal to, and then CB is 3, and BF is 9, so 3 times 12, because that way I need to get the entire length of CF, right? So x squared is equal to 36, so x has to be 6 for number 7. Okay. We're going to skip over number 8. I don't have you doing this one on your test, so we're not going to worry about that one. We do talk about on our test, though, a hexagon. So if you look at the hexagon, just make sure you can do n minus 2 times 180 to figure out the total degrees. And then that should help you with that question, okay? Number 9, find the value of the variable. You're just going to set these equal to one another. So 5x minus 4 equals 3x plus 6. 2x is equal to 10, so x has to be 5 for number 9. Number 10, this one, because we have our diameter, across from the diameter is a right angle. So to find r, we can use the Pythagorean theorem. So 12 squared plus r squared is equal to 6 plus r squared, okay? So we would come up with 144 plus r squared is equal to 6 plus r squared. I'm just going to show my FOIL steps here. 36 plus r squared plus 6r, so first, outer, inner, last. So I got 36 plus 12r plus r squared, okay? Here's the nice thing, when I start to try to find my r, if I subtract r squared, they cancel out. So 144 equals 36 plus 12r, boop, minus 36 from both sides. I'm going to get 108 equals 12r, so r has to be 9. Okay. Prove or disprove that the point 2 square root 2 negative 1 lies on the circle centered, so here's my center, H, okay, and contains the point negative 1 comma 4. So the first thing we got to make sure we know is what in the world is my equation for a circle. So this comes from lesson 10.7, where you have your x minus h squared plus y minus k squared is equal to your radius. So if you haven't had a chance to see that video, probably want to do that, but one thing we want to start by looking at is, do these 2 points have the same radius? Okay, so when we start looking at this one, you want to have your center points and then see if they have the same radius. So I'm going to start with 2 square root 2, negative 1. So this would be x1, y1, and then we'll say this is x2, y2. Okay? So I'm going to find the distance of both of those, see what my radius could be. So x2 minus x1, that'd be 0 minus 2 square root 2 squared plus 2 minus negative 1 squared. Okay? 0 minus negative 2 square root 2 is just going to be negative 2 square root 2 squared. And then 2 minus negative 1 is 3 squared. Okay? So, as I'm going through this one, when you square negative 2, you're going to get 4. And when you square a square root, you just get 2. So this would be 8 plus 9. So the square root of 17. Okay? So that's going to be radius option number 1. Then for option number 2, this can be your x1, y1, x2, y2 again. So my x1, negative 1 minus 0 squared plus 4 minus negative 1 squared. Okay? I'm going to get negative 1 minus 0 is negative 1. And then 4 minus negative 1 is 5. So what that ends up being is 1 plus 25, which is the square root of 26. So if you're looking at both of these, they do not match. So we would have to say, no, 2 square root 2, negative 1 isn't on the circle. Okay? If their radiuses did match, then we would say yes, because they would have the same distance from that center point. Okay? Number 12, just talking about some proofs here. How could ST, that arc, be equal to RQ? So some things we want to consider. The first theorem that comes to mind is from my theorem sheet 10.19. This was your equidistance chords. For these, I might actually end up typing stuff. Okay, just because I see that they're equidistant from the markings here, so that's going to prove that the chords can be equal, ST and RQ as a chord. So then because of that, then I use theorem, I'm going to make these a little bit larger too. Then I use theorem from my sheet 10.16, your congruent chords theorem, to state that if I have a concurrent chord, then I have congruent arcs. Okay? Number 13, same deal. How can I prove that JM's arc is the same as LM's arc? So the first thing I see is I know that segment CJ is equal to segment CL, and CK is equal to CK, so the triangles are congruent. So since triangles are congruent, then angle LCK is congruent to angle JCK. And then I use, from my theorem sheet 10.4, congruent central angles to show that the arcs are also congruent because of congruent angles. Okay? And then our last one we get to look at, arc DG and arc FG. So the way I started this one is I thought of GE bisects DF. So DG is congruent to FG. Then I use theorem from my sheet 10.6, the corresponding chords theorem. probably would help if I spell that right. To show that arc DG is matching arc FG since the segments inside are corresponding to the arcs and are congruent. Okay, that will conclude our Chapter 10 test review. Thanks so much for tuning in. Hopefully this video helped you, and good luck on your test next class. Have a great day.